In this lesson, we're going to look at quadratic functions and we're going to look at their graphs. So we're going to look at graphing quadratic functions in a few different forms. So the first thing we want to look at is examining the graph of x squared when we have a few things that changes. So we've looked at graphing x squared or f of x equals x squared in a previous section. And remember, if we looked at a, that value in front of x squared, and if it was positive, the parabola opened upward, versus if it was negative, the parabola opened downward. And so that would look different depending on what that value in front of x squared was. So those are two things we've looked at before. The highest or lowest point on that graph is called the vertex. So highest point or lowest point is called the vertex. And so these points here would be our vertex. Now the line that goes through that vertex is called an axis of symmetry. And that's going to go through the middle of your parabola. And so if we have a parabola, I'm just going to draw a big one that opens up. The vertex would be right there. And so that axis of symmetry would be this line that goes through there. And you can see it cuts that parabola in half. So if we're graphing a quadratic function, and that quadratic function is in the form of f of x equals x squared plus k. So we still have just x squared, but then we've got this value that's being added at the end. So if that k value is positive, the graph is going to be shifted up. So we're still going to have that graph of x squared, but it's going to shift up k units. Versus if we have a k value that's negative, then that graph is going to shift down k units. The vertex is going to be 0k. So in our parent function, or in the function y equals x squared, that vertex was at 0, 0. But when it shifts, if it shifts up or if it shifts down, that vertex is going to change. It's going to change based on that k value. The axis of symmetry is not going to change. It's still going to be the y-axis, so it's still going to fall at x equals 0. So if we look at these examples, we've got the blue one, which is right here. So that is my basic parent function, x squared. So you can see my vertex right here at 0, 0, facing up, and then I could have this axis of symmetry going right through here at x equals 0. Then if I look at g of x, which is x squared plus 3, this 3 tells me that I'm moving up 3 units. So you can see that from this blue graph, it shifted up 1, 2, 3 units. The shape didn't change. The graph just said it shifted up 3 units. Sorry. If we look at h of x, based on my function, this is telling me that it shifted down 3 units. And again, I can look here and see that from my blue graph, it shifted down 3 units, but the shape didn't change. And in each of these, I still have an axis of symmetry that goes through this y-axis. So the axis of symmetry for each of these is still at x equals 0, axis of symmetry. And then if we look at the vertex for each of these, so the vertex here for that red function, it shifted up 3. So it's at 0, 3. The vertex for the green function, it shifted down 3. So it's at 0, negative 3. And again, my parent function, that vertex is 0, 0. Okay. So now let's look at what happens if we have a value inside those parentheses with our x. So if we have this value of h, and h is positive, then our graph is going to shift to the right h units. If we have a value of h that's negative, then our graph is going to shift to the left h units. Since our graph is shifting left or right, that means that our vertex is going to change, and also our axis of symmetry is going to change. And it's all going to be based on that h value. So let's look at some examples here. So if we look at our parent function, that's the blue one, versus g of x, which is x minus 3. So right here, okay, remember our function was x, or f of x, equals x minus h squared. So if h is positive, the graph is going to shift to the right. So that means that if I'm looking at the red function, my 3 is positive because this sign didn't change. And so I could plug in a positive 3 and it would still be x minus 3. That's a little tricky sometimes. So that means that it shifted to the right 3 units. You can see that the vertex changed to 3, 0. The axis of symmetry also changed here. So this new axis of symmetry is at 3, 0, or sorry, x equals 3. So axis of symmetry right here, x equals 3. If I look at the green one, I can see here, well, if I plugged in a positive 3, that should stay x minus 3. But if I plug in a negative 3, 2 negatives make a positive. So I would have x minus negative 3. And that's where you would get the x plus 3. That's why this works out to be going to the left 3 units. And my vertex is negative 3. So negative 3, 0. Also, my axis of symmetry is at x equals negative 3. So what if both things happen? So what if I have a k and an h value? Then the parabola is still going to have the same shape as y equals x squared. The vertex, if you notice when we put those two things together, the vertex is going to be h, k. The axis of symmetry is going to be x equals h. So this formula is very important, the form of this function. So make sure you have that written down. So again, if we look at this one, so again, our parent function is x squared. If we look at the red function, we can see that our 2 tells us that we moved to the right 2 places. The 4 tells us that we moved up 4 places. So right 2, up 4. That means our new vertex would be at the point 2, 4. Our axis of symmetry is going to match with the x value of the vertex. So x equals 2. So if we have f of x equals ax squared and a is positive, then the parabola is going to open upward. If a is negative, the parabola is going to open downward. If a is a number that's bigger than 1, the graph of the parabola is going to be narrower than the graph of x squared. But if a is less than 1, then the graph of the parabola is wider. So any number bigger than 1 is going to make that graph get narrow, but any number smaller than 1 is going to make that graph get wide. So let's look at a couple of examples you could see. If we look at our parent function, again, that's the blue one. You can see this is my normal graph, okay? Then if I look at, sorry, I did the wrong one. I was used to the other ones being blue. This is my parent function. Forgive me on that one, so sorry. So the red one is my parent function, okay? So this one right here, this is y equals x squared. So that's what we're comparing to. If you look at the blue graph, so 3 is a number that a value is bigger than 1. So we should expect this to get narrow. And it does. You can see that when we graph it, right here, that gets narrower. So y equals 3x squared is narrower. If we look at the green graph, this is an a value that's less than 1. So that one should get wider, and it does. You can see this gets wider because the a value is less than 1. Okay. All right, so let's look at an example where we could sketch this graph, give the vertex and the axis of symmetry. So we've got our parent function x squared, and then we're adding 3. So plus 3 at the end means it's going up 3 units. So our original vertex is at 0, 0. That means this one is going to go up from 0, 0, up 1, 2, 3. So it should be right here, and that should be our vertex. So we know just based on our equation that our vertex should be at 0, 3. And then that means our axis of symmetry should be at x equals 0 because it's always going to be the x value of your vertex. Now, if we wanted to get some more points, we could do that by hand, but I'm also going to show you how you can use your calculator. So in our calculator, if you press y equals, okay, we can graph this. So we can graph it, press the X button, which is the XTON key. You can see it right beside alpha. And then we're going to square plus 3. Then if you want to see the graph, you can press the graph button. It's in the top right. So that's what it should look like. You can also get a table of values, and you can do that by pressing the second button and then the graph button. And so now we have a table of values, and we can scroll through that table to get some values that are around our vertex. And so in this, I can say, okay, well, I know my vertex is at 0, 3. So negative 1, 4 would be a good one. Negative 1, 4, 1, 4, maybe negative 2, 7, and 2, 7. And so then I could connect these in a nice smooth curve, add arrows on the end, and you have your parabola. Okay, let's get example F. So again, here we've got a -6, but this time it's inside the parentheses. That means that it moved to the right 6. Didn't move up or down, so that means that my vertex is not at 0, 0. It moved over 6. So it should be right here. My vertex should be at 6, 0, which means my axis of symmetry should be at x equals 6. Again, we can use our calculator to help us get points. We're going to make sure we put that x minus 6 in parentheses, and then we're going to square it. Again, I can see my graph by pressing graph. I can get a table of values. Second table. Okay, these numbers are super large, so I'm going to scroll down. I'm going to find my vertex, and then I'm going to get some points around it. So 7, 1. It's a good one. 6, 0 I've got. 5, 1. 4, 4. I know that 8, 4 is off, but I can still kind of graph it to give me an idea. And then I can connect these. Okay. All right, let's look at this one. So, number 3. We've got a little bit more going on here, but we could still get our vertex because this tells me that I'm going to the left 5, and this tells me that I'm going down 3. So my vertex is going to be at HK, so that means that I'm at negative 5, negative 3, and my axis of symmetry is going to be at x equals negative 5. But we can use our calculator to help us graph and get our points. So negative 4 x plus 5 squared minus 3. Now this one's opening down because there's a negative. Okay, that 4 made it get a little bit narrower. But we can get our table, second graph. Okay, well those numbers are very large, but that's because I need to move over towards my vertex. So my vertex was negative 5, negative 3. So 3, all right, so right there. Then I've got negative 6, negative 7, and negative 4, negative 7. That's all that's really going to fit on this graph, so we can use that. And there we go. All right, last one. So this tells us that I'm going to the right 4, and that means up 3. So my vertex, remember, is HK. So 4, 3, which means my axis of symmetry is x equals 4. But we can go to our calculator to help get some points. So x minus 4 squared plus 3. It's opening up because it's positive. I'm going to go second graph to get my table. I need to find values close to my vertex. So 4, 3. And then I've got 5, 4. 3, 4, 6, 7, and connect these. And there you go. And so that is how you would graph these using the calculator and using the vertex.